Look at a number like 5. On its own, it represents exactly 5 things. But once that 5 is placed inside a multi-digit number, its worth depends entirely on the location it occupies. Welcome to the Acorn Hoard. I am the Math Sheba. This mossy oak slope holds the winter store in a series of nested caches. Hazel the squirrel begins her work here, at the ones cache, the smallest level of the slope. Every cache moving up the slope holds exactly 10 times the amount of the cache sitting directly to its right. That 10-for-1 stair, climbing and descending, determines how every amount in the hoard is measured and stored. Now watch as Hazel carries a single acorn up the slope, moving from the small ones cache to the tens basket. When she collects 10 individual acorns, they pour into the larger container and consolidate into a single unit that is 10 times the size of the original. These labels show the scale of the consolidation. 10 ones become 1 10, and 10 of those baskets become a single 100. Moving exactly one place to the left always multiplies a digit's value by 10. Look at the number 5,550. Even though the digits look the same, we need to compare the 5 in the hundreds place to the 5 in the tens place. The 5 in the hundreds place represents 500 acorns. The 5 sitting directly to its right is only worth 50. Because one step left multiplies the value by 10, 500 is exactly 10 times larger than 50. In the number 7,070, the identical digits are separated by an extra place value slot. The first 7 is in the thousands place, representing 7,000. The second 7 is in the tens place, worth 70. Notice how Hazel has to scamper across 2 separate caches to get all the way from the tens to the thousands. Since each move left multiplies the value by 10, moving 2 spaces means multiplying by 10 twice. That makes the 7,000 exactly 100 times larger than the 70. Now consider what happens to a digit's value when it moves backward, from left to right. Watch closely as Hazel carries a single acorn down the slope, from the large 100 hollow into the smaller tens basket. Stepping one place to the right divides the digit's value by 10. This division means the new value is precisely 1/10 of what it was before. Place value is a bidirectional multiplier. Moving left scales up by tens, while moving right scales down by tenths. In this system, this place is exactly 10 times the place to its right. This rule tracks 10-for-1 scale changes for any digit, no matter how large the number becomes. Hazel has safely buried her very last acorn in the thick moss, and her massive winter hoard is finally secure. 10 times to the left, 1/10 to the right. I'll see you at the next bend.
Before you go, in the number 4,444, exactly how many times bigger is the leftmost 4 than the rightmost 4?